Problem 28 on page 260. Even though we're calculating a confidence interval, we have to be very careful that this is not a confidence interval for a mean. This is a confidence interval for a proportion. So with a population mean confidence interval, if the population standard deviation is known, you use z-scores. And that's all built into the spreadsheets that you have. So if you're doing a population, you use the spreadsheet that I've given you, the worksheet in particular. So pay attention to that when which worksheet you're on. If you are not given the population standard deviation, then you use t-scores, which would be the sample confidence interval. And in this case, which would use t-values, by the way, and in this particular case, you have a proportion, which is going back to z-scores. So in the workbook that I've given you, there will be at least 3 tabs at the bottom. One will be, so you have to be careful which one you're on. One will be for population confidence interval, one for mean, one will be confidence interval for sample mean, and then you'll also have one for confidence interval for proportion. So be careful with that. That's the key to this, especially because you've been provided with the spreadsheet. So in this particular case, in problem number 28, which has to do with purchasing additional telephone lines, you can see that you have a sample of 500 subscribers. 135 would upgrade to a new cell phone at a reduced cost. You want a 99% confidence interval. And so you put those 3 numbers in. This is proportion. So the probability of success is that somebody would upgrade. Probability of failure is somebody would not upgrade. Cell phone companies know this. They need to know this kind of information. They pay a lot of attention to this, trying to find out what percentage of people were willing to upgrade. So you wind up with a lower limit of 0.218, etc., which is basically 22%, and an upper limit of 0.321, which is an upper limit of 0.32, which is 32%. So just like we've dealt with confidence intervals in this entire chapter, you are 99% sure that between 22 to 32%, with the average being 27%, the average is always in the middle of that. So you're 99% sure that at least 22% will upgrade to 32%. That the actual population, if you actually were to do a marketing campaign on this, that you would wind up with 22 to 32% of people who would upgrade. Again, with 1% error, which is the level of significance, you will have 1% or 0.5% below 0.22 and 0.5% above 0.32 or 32%. So in this case, in part B, as you can see, the manager can infer that the proportion of households will be between 22 and 32% if you can reduce the installation costs. So people are willing to upgrade if they can have a reduced installation cost.